So I think it was June or the end or start of July, but yeah. So now this is ADMAT 2020. The first one says right here, the expression AB plus 3C minus 3B minus AC is equal to, let's go ahead. All we need to do now is group like terms. So now we have AB, and I can rewrite it as minus 3B plus 3C minus AC. And I realize I can factor out B, sorry, and I'm left back with A minus 3, close that bracket. Then I can factor out, that looks like minus C, and I'm left back with factoring out minus C. From this, I'm left back with 3. Let's factor out positive C plus C, and I'm left back with 3 minus A. But 3 minus is not what I want. So yeah, it's best if I factor out minus C to be left back with minus 3 plus A. But minus 3 plus A in here is the same as A minus 3. So this works out simply to be A minus 3 times B minus C. That's the answer. That's number 1. Yeah, nice. So for 2020, A minus 3, B minus C, which is option D. Nice. Now the next part says 1 over x plus 3 times x squared minus 9. We need to express this as a single fraction. So let's do this on the whiteboard. We have 1 over x plus 3, and then, all right, it's not writing too well here, plus, and that right here is 3 over x squared minus 9, 3 over x squared minus 9. Now, first thing you have to remember is x squared minus 9, that is really the difference of 2 squares. So really and truly, this is really 1 over x plus 3 plus this x squared minus 9. You can break it up. Yeah, man, you can break up x squared minus 9 as x plus 3 times x minus 3. So this is x plus 3 times x minus 3. Yeah, man. So now to write it as one fraction, it's going to be, of course, the x plus 3 times the x minus 3. And so now we say x plus 3 into x plus 3 times x minus 3. That leaves x minus 3. So in the numerator, we're left back with 1 times, in bracket, x minus 3, close the bracket, and then you put your plus 3. That's it. So simplify our numerator, that becomes x minus 3 plus 3 is just x. In the numerator, it's just x over, then remember in the denominator is the difference of 2 squared, which is still x squared minus 9. Yeah, man, nice. This right here is the difference of 2 squared, so it's x over x squared minus 9. So this is option B, x over x squared minus 9. Easy. Next part now says we need to complete the square, and it says f of x is 1 minus 4x minus 2x squared. So to do that, f of x, you write that down. F of x is equal to 1 minus 2x minus, was that 4x squared? 1 minus 4x minus 2x squared. We want to complete the square. So to complete the square, first thing we need to find is h And we know that h is equal to b over 2a, and b over 2a is going to be negative 4 over 2 times a, which is 2 times, this is a is your coefficient of your x squared term. This is your a, so it's 2 times negative 2. So that works out to be negative 4 over negative 4, which is 1. So since we have that now, the next thing we do need to do is find f of negative 1. F of negative 1, we need negative 1 for the x value at the turning point. If h equal 1, then the x value at the turning point is negative 1. All right, so find f of minus 1, that would be 1. Plug x as minus 1 right here, minus 4 times minus 1. And then what we get is minus 2 times minus 1 all squared. That's going to be equal to 1 minus minus 4 becomes 1 plus 5. And then we have minus 1 squared is 1. 1 times minus 2 is minus 2. So end up get 1 plus 5 is 6. 6 minus 2. 6 minus 2 is 4. So that means we can rewrite f of x. We can rewrite f of x as, remember, f of x can always be written in the form a in bracket x plus h, a in bracket x plus h squared plus k. Yeah, man. But then we just found what a was. A is minus 2. So it's minus 2 times in bracket x plus h, which is going to be x plus 1 square plus k, and k is 4, so put plus 4, and that's it. Easy. So let's look right here now. Did we get 4? They don't have 4 right here. Let's see what we have. Minus an, oh shoot, my bad. Minus, this becomes, it should have been 4 right here. Nice, we can fix that. 1 plus 4 is 5, 5 minus 2 is 3. And then they didn't want it in this form, you could actually put, this is 3, then put the 3 to the front, put the 3 to the front to make it be 3 minus 2 times x plus 1 all squared. So this is it, 3 minus 2 times x plus 1 all squared. All right, now we'll finish. So that is 3 times 2 minus x plus 1 all squared is option C. Nice. Now this question here now says, if x squared minus 6x plus 13 is this, then we need to find a, h, and k. Always remember the formula that h is b over 2a, right? H is b over 2a. We already know that a is positive 1, which is the coefficient of x squared. So b over 2a is h, which is going to be, let's see, b is negative 6 over 2. Negative 6 over 2 is negative 3. There's only one answer with negative 3, which is right here. So let's see it there. This is it, b. We don't even need to check and find k because there's only one answer with the minus 3. All right. And if you don't believe me, look at this. We're going to actually do it. If you want to use a calculator, there's a very smart calculator that can do it. This Casio here can help you find your x value at the turning point and your y value at the turning point. Look at this. All you do is go to mode and you go on equation 5. You click on quadratic tree. Solve it equals 0 now. Coefficient of a is 1. Enter that. B is minus 6. C is 13 from the question. Solve it now. Well, we don't really want to solve it. Click press equal. See the x value at the minimum point is 3. And so h is minus 3. Then the y value at the minimum is 4. See the k is 4, which is the y value at the minimum. So that's how the calculator did there. So that is option B. Nice. Continuing. Question 5, it says a quadratic equation is such that the sum of its roots is minus 2 over 3 and its product is 3 over 4. What is the quadratic equation? Remember that a quadratic equation can be written in the form x squared minus the sum of the roots times x plus the product of the roots equals 0. All right, so then tell us that the sum is negative 2 over 3. So that means the equation can be written as x squared minus the sum minus 2 over 3 become plus 2 over 3. So it's x squared plus 2 over 3 times x plus the product, and the product is 3 over 4. So you get plus 3 over 4. Now, of course, as you can see right here, this none of them here, this answer down there. So what you're gonna have to do is multiply this entire equation by 12. Multiplying this equation by 12, 12 times x squared, that will give you 12x squared. Then you multiply 12 times 2 over 3. If you're not sure, put it in your calculator. 12 times 2 over 3, just to be safe. Let's go. 12 times 2 over 3. That's 8. So right here, so this is now plus 8x. And then we have 12 times 3 over 4, that is plus 9. And that equals 0. So that's the answer. Somewhere will give us all the plus there. That look like option A. That's it, easy, soft. Now this question right here is an inequality. It says, find the set of values of x for which 3x plus 2 is greater than x minus 2. To do this, let me reduce down this font size first. To do this question now, easy. What we're gonna do is we have 3x plus 2 is greater than x plus minus 2. So bring over the x to the other side. Bring over the x over here to get 2x is greater than. Bring over this plus 2 over here. So it becomes minus 2, so we get greater than minus 4. Then you divide through by 2 to then say x is greater than negative 2. Easy. That is option D. Soft. Nice. Now this one right here now, it says find the values of x for which 3x minus 2 over 2x plus 1 is less than or equal to 0. To do this, the first thing we need to do is multiply. We're going to multiply through by 2x plus 1 all squared. You multiply by, let me even go write it on the whiteboard so we'll have a little bit more space. 3x minus 2 over 3x minus 2 over 2x plus 1 and this is let me see, this is less than or equal to 0. So the first thing we're required to do, we need to multiply through by 2x plus 1. That's the first thing that we need to do, multiply through by 2x plus 1 all squared. If we multiply through by 2x plus 1 all squared, what's going to happen is that we're going to end up getting 3x minus 2 over, look at this, multiplying by the square of it. Remember, square really means you have 2x plus 1 here, so then another 2x plus 1 here, so yeah man, that's what square mean. You're multiplying by itself twice. That's what square mean. And then we're dividing by a 2x plus 1 down here. We're dividing by a 2x plus 1. And then that is going to be less than or equal to 0. So what's going to end up happening now is that this 2x plus 1 cancels this 2x plus 1 and it leads to a quadratic. So it leads now to a quadratic. 3x minus 2 times 2x plus 1 is less than 0. I know I'm not writing that pretty, but yeah. So this is less than or equal to 0. So now you end up with a quadratic equation looking like this. I want where the quadratic is less than or equal to 0, so I want down here. Now right here, so now this has to be when x is 2 over 3. That's 2 over 3. And this have to be when x is minus a half. And then the solution we want are in between here. So that means that x is going to be bigger than or equal to minus a half. Yeah, man. But at the same time, x is going to be less than or equal to 2 over 3. All right, and that's it. That's it. So x is less than or equal to 2 over 3, but bigger than or equal to minus a half. Where is that one? This is it right here. All right, so right here, so you should have it's right here. All right, so that is that right here. That is this part right here. X is less than or equal to 2 over 3, but bigger than or equal to minus a half. All right, nice. That's the solution. Next part now, it says if f of x is minus 2 over 9 x cubed, where x is between -3 and 3, then what is the range? To find what is the range, what you're going to do is plug in when x equals 3 in the function. I can't even bother type it up. All right, so we're just going to use a calculator. If you plug in 3, look at this. Minus 2 over 9, and you multiply it by 3 cubed, look what you get. You get -6, so that's the lowest y value. This is the lowest y value. And then when you plug in minus 3 now, look at this, you get 6. So that means that f of x is between -6 and 6, which is right here. So that is part C. You realize when we plug in, we get -6 and +6. Nice. All right, so just to show it, calculator, here it is. Nice. All right, so finish the first 8 questions. So we moving right along. This is now question 9. It says a function is defined by f of x is 1 over x plus 1, and we need to find f inverse of 1. There are 2 ways we can do this question. To find f inverse of 1, pretty much they're asking you to find they're asking you to solve f of x equal to 1. That's what they're asking you to do, solve f of x equal to 1. So now if you were to set this function equal to 1, you cross multiply and you end up getting 1 is equal to x plus 1. Yeah, and then we subtract 1 from both sides, and so x equals 0. So the value f inverse of 1 is going to be 0. See there? 0. Now let's do it method 2. Method 2 is if you wanted to actually find the inverse. So we have f is equal to 1 over x plus 1. So to find the inverse, we know that we interchange x and y. So we can end up say x is equal to 1 over y plus 1. And now we need to make that y the subject. So to make y the subject, we will get that y plus 1 is equal to 1 over x. And then we subtract 1 from both sides to say y is equal to 1 over x minus 1. Now remember, y right here so is f inverse. So this is now f inverse. So all we need to do now to find f inverse of 1 is to plug in 1 into the function. So f inverse of 1 is equal to 1 over, replace x with 1, minus 1. 1 minus 1 is 0. So you could have done it the normal way, this is the boring way, or you could have done it by using the property that we can connect the inverse of a function to this right here. So this right here is 0. Nice. Now the next part of the question says f of x is 2x minus 5 and g of x is 4 plus 3 over x, and we need to find g f of x. So we need to put f into g. So let us go ahead and do that. So f of x is 2x minus 5. Let's write that down. F of x is equal to 2x minus 5. And we have g right here. G is 4 plus 3 over x. All right. So we have g of x is equal to 4 plus 3 over x. And what we're required to find is g f of x. So we're going to put f into g. So let us put f into g right here. So g f of x, I'm just going to write g f. G f is equal to, put f into g, it's going to be 4 plus 3 over, you replace x with 2x minus 5. 2x minus 5, that is gf. But then now you need to write it as one fraction. So it's going to be 4 times 2x minus 5 plus 3 over 2x minus 5. This is how we write it as one fraction. Yeah, man, we're writing it as one fraction. So what we're going to end up getting now is 4 times 2 is 8x. And then 4 times minus 5 is minus 20. Then we have plus 3. So that is giving us, that look like 8x minus 17 over 2x minus 5. All right, so you can write that down. This is 8x minus 17 over 2x minus 5. That's that one right there. Nice. 8x minus 17 over 2x minus 5, and it is option C. That right there. Nice. All right, moving right along, it says, which of the following is a function? It is a function if we can do our vertical line test and it only intersects at one point. So we're going to pop our vertical line. This is a function, so this is clearly option A, only one point of intersection. So this is a function by doing the vertical line test. All right, so nice. So that's option A. All right, easy. Let's go to question 12. Question 12 said to rationalize this right here. To rationalize it, all we do is multiply by the conjugate of the denominator. But in this case, what I'm going to do right here is I'm just going to pop out the calculator. See it here? Just get a calculator and put in the root of 5 minus 1 over, divide that by 1 plus the root of 5. So we do that, and see there, give it 3 minus 5 over root 2. All right, so the calculator gives me that this is 3 minus root 5 over 2. So what that means is I can factor out the half. If you factor out the half, you end up getting, this is going to be 3 minus root 5. 3 minus root 5 is a half of 3 minus root 5. And that is going to be option D. Nice and easy stuff. All right. So now we need this now. It says find the value of 2 to the z, where z is equal to, it says z is 5 plus 2 log base 3. All right, so let's write that down here on the white screen. So they gave us that z is equal to 5 plus log 2 of 3. So this is 5 plus of 2 plus log to base 2 of 3. And then now what you can do is write it as 1 log. So z is actually bring up the power. So this is actually log to base 2 of 2 to the 5th power, 2 to the 5th power, and then it is being multiplied by 3. Now 2 to the 5th power is 32. And 32 times 3 is 96. So z is going to be log to base 2 of 96. Now we don't done yet. What the question want? The question want 2 to the z. So let's work out what they want. So then now 2 to the z is equal to, let's fix that. 2 to the z is equal to 2 to this z there, log to base 2 of 96. So it's log to base 2 of 96. This is what we want. This now is 2 to the z, but then now you might say, but this don't look too proper. We can't just look and figure out what is this. Well, there are two ways we can approach this now. Let's look at way one. Way one is to find what z is, or simplify an expression with z. Remember that logarithm definition would be telling us that 96 is then saying that 96 is equal to 2 to the z. Ah, look at that. By doing it this way, we're saying that 2 to the z is 96. So if you did it this way, you're done. Using the definition of logarithm, 2 to the z is 96. Remember, definition says base to the power equal the number. 2 to the z is 96. What you know is that 2 to the z is 2 to log to base 2 of 96. What you can do is use change of base law and realize that log to base 2 of 96, that is actually equal to log to base 10 of 96 over log to base 10 of 2. And when you do this now, you just work out this in a calculator. Whatever you get, when you put this in a calculator, let's put that in a calculator. Let's use this one. So we use log to base 10 of 96. And then we divide that by log to base 10 of 2. That's log of 2. When you work that out, this is what you get. And then you raise 2 to this now. 2 raised to that. So you get a 96 there. Nice. So any method works. And so the answer is, of course, 96. So this is method 1. We can write M1. And this right here is method 2. So this gives you 6.5. And then we work out 2 to the 6.5. So any method works, and it gives you 96. Nice. So method 1 and method 2. Any way you want to do it is fine. Nice and easy. So this is method 1 and method 2. That's 96. Option C. All right. So moving right along. Question 14. It says, given that log to base 2 of x cubed equals 6, then what is x? By definition of logarithm, base of 2 to the power of 6, 2 to the 6, is equal to x cubed. But what is 2 to the 6? 2 to the 6 is 64. So that means 64 is equal to x cubed. Now we know that 4 cubed equals 64, and so this has to be 4. Nice. That's really nice so far, soft. All right, question 15. Let's look at which statement is true. It tells us that we have log to base a of p times q. Now we know that the log of p times q is log of p plus the log of q. Log of p plus the log of q. And so statement 1 is definitely not true. Statement 1 is not true. All right, so since statement 1 is not true, it's only going to be option C, because anything with statement 1 out. All right, so that's it. We know this one is clearly true. This is the power law, where we can carry down the power for logarithm. And we know that the log of the quotient is the log of the difference. All right, so that is true. 2 and 3 is true. That's option C. All right, nice. Let's look at question 16 here. Question 16 says, given that 3 times 27 raised to the 2x is 9 to the x, find the value of x. To do this, we're going to use indices. So we have 3 to the 1 times, this 27 is 3 cubed. So we have 3 cubed, that is being raised to the 2x, and that's equal to 9 to the x, that is now 3 squared raised to the power x. So now what we can do is rewrite this now as This is 3 to the, when the bases are the same, we add the powers. So it's 1 plus, but we have to multiply 3 times 2x to get 6x. And then that is equal to 3 to the, we multiply 2 times 3. When you multiply 2 times 3, we get 6. So that means 1 plus 6x equal 6. All right, when we equate the powers, that means 1 plus 6x equals 6. 1 plus 6x equals 6. And so what we can do then is, right here, we're going to bring over the 6 over here. Let's see, bring over the 6 over here. Did we 2x here, 3 times 2, 3 cubed is 27. Yes, 3 cubed is 27, so that's fine. And 9 is 3 squared. Oh, this was x. Where did this 3 come from? This should have been x. My apologies. This was x. Let's fix this. This was x. So this should have been 3 to the 2x. Fix this right here. 3 to the 2x. Erase that. And so we're equating 1 plus 6x equal 2x. All right, so this should have been 2x up here. So then now bring over the 6x over here to get minus 4x. And minus 4x is equal to 1. So divide both sides by negative 4. And so that means x equal 1 over 4. Because then the negative 4's cancel. That's minus 1 over 4. That's option B. All right. All right, so now question 17. Question 17 says, the sum of the first n terms of a geometric series is 4 to the n. For this series, it asks, which statement true? The common ratio is -1, we don't know. Let's look at it. Sn is 4 to the n minus 1. All right, then tell me that Sn, meaning the sum of n terms, is given by 4 to the n minus 1. My apologies. So S1 will give you the first term. So S1 will give you the sum of one term. So that would be 4 to the 1 minus 1, which would be 3. So that is telling us that the first term is 3. So the first term is 3. All right, cool. Now look what else it tells me now. If we put in 2, S2 is going to be equal to 4 to the second power minus 1. 4 squared is 16. 16 minus 1 is 15. So that means that the first term and the second term, so 3 plus the second term, let's call the second term x equal 15. And so that means that the second term is 12. So the second term is 12. The second term is 12 because the sum of the first two terms then must be 15. So the second term have to be 12. Let's see if that can help you now. So the first three terms are 3, 12, and 48. All right, so we need to go one more then. So going one more then, that would mean that S3, which would give us the sum of the first three terms, is 4 cubed. This is 4 cubed minus 1, which is 64 minus 1 is 63. And if the first three term is 63, the sum of them, that means that 3 plus the 12 plus the third term x equals 63. And so that means that if you subtract 3 and subtract 12, x must be 48. So that's the third term. The third term is 48. Third term is 48. So that's good. Third term is 48. Cool. So we're nice with that. The third term is 48. So this is true. Number 2 is true. Now, is the common ratio -1? The common ratio would be second term divided by the first term. So the common ratio R would be 12 over 3, which is 4. And the common ratio you could easily use is 48 over 12. That's how we find common ratio. Common ratio is found by dividing the second term by the first term. That would be 4. All right. And so because the common ratio is 4, this one is not true. This is not true. Common ratio is not -1, so this one wrong. Anything we do one wrong, so it is clearly option C. Easy. So, all right. All right, now let's look at question 18. Question 18 says find the sum from k equal 1 to 3 of 1 over k. This is just equal to plug in k as 1, you get 1, plus plug in k as 2, you get 1 over 2, plus plug in k as 3, you get 1 over 3. Then add them up. 1 plus a half is 1 and a half plus 1 over 3. That's, all right, I'm fed up. I just want to put it in the calculator. I'm fed up. 1 plus a half plus 1 over 3. It's sad that I'm using the calculator, but that's it. That's 11 over 6. All right, so that's 11 over 6. So 11 over 6 to get, that is option D. Now look at this right here. You didn't have to do it this way. You could actually take out this calculator here and look at this. You can actually just put in alpha and this, or the one product, shift and this. That's the sum from x equal 1 to 3 of the expression is 1 over, this is 1 over x. So that's alpha, then this. See there, 11 over 6. Easy. So either you want to do it yourself or you can use the calculator. Nice. So let's continue now. Question 19 says, find the common ratio of this geometric progression. The common ratio is the second term divided by the first term. So it's 12 divided by 8. That's the common ratio. 12 over 8 actually simplifies to be, what is 12 over 8? 4 over 3, or is it 3 over 2? I'm not so sure. I'm going to put in my calculator. 12 over 8, which is 3 over 2. That's the common ratio, 3 over 2. Always remember the common ratio R is the second term divided by the first term. It's T2 divided by T1. Term 2 over term 1. 12 divided by 8 or 18 divided by 12. Nice. Now it tells us that the sum of the odd integers between 10 and 50 is, so you want to add up all the odd numbers between 10 and 50. So what you can do is write it out. All of the odd number then between 10 and 50 is 11 plus 13 plus 15 plus 17 plus 19 plus 21 plus, and you can continue all the way up to 49. That's how you find the sum of all the odd numbers. Now you can actually just put it in the calculator, or you can do this. Realize that the first term is 11. Realize it have a common difference of, this would have a common difference of 2. And then you can use sum of an arithmetic progression. And the sum of an, but first thing we need to know is how many terms are there, how many terms is in this sequence right here. But guess what? The last term is 49. So remember that the last term L is equal to A, and A is the first term of 11. Going to be 11 plus n minus 1. N minus 1 times your common difference, D. Your common difference in this case is 2. And remember your last term L in this case is 49. Yeah man, the last term is 49. So use that now. 49 equal this. Bring over here the 11 to get 38 is equal to 2n minus 2. And then now bring over the 2 over here to get 40 equal to n. Then divide through by 2, so n equal 20. Since n equal 20, now we can find the sum of all the odd numbers is going to be equal to n over 2 So the sum of all the odd numbers is n over 2 times in bracket 2a plus n minus 1 times d. This is a formula. This is a formula we're using. And so this is going to be equal to sum of all the odd numbers is n, which is 20, over 2, which is 10, times in bracket 2a, which is 2 times the first term of 11, plus n minus 1. This is now 20 minus 1, which is 19, times the common difference of 2. So all of this, you put that in a calculator, or you can just work it out yourself. But let's put it in our, no, let's work it out ourselves, just to test our brain power. This is now 22 plus, let me see, 2 times 19 is 38. 38 plus 22 is 60. And then 60 times 10 is 600. Is that true? Let's go again. This time this is 38 plus 22. 22 and 30, yeah, that's 60 times 10 is 600. So that's 600 for the answer. Nice. 600. All right, now moving on. The next one says the coordinates of the circle. The center of the circle. The center of the circle is always this one right here. It's always minus, so it's positive 1, then minus 3, because it's y minus minus 3. You always want to put it in standard form. So the center is 1 minus 3. That's option C right there. So yes, we're nice. Now question 22 says, find the point of intersection with the line and the curve. So first thing we need to do is right here, so this line, we can make y the subject, bring over the x, really and truly they're giving you that y is equal to x plus 2. So let us now solve them simultaneously. So let's go to the whiteboard, and then we can do it right here. Y is equal to x plus 2, and then we have x squared plus y squared equal 10. So we're going to substitute the y as x plus 2. So really and truly now we have x squared plus x plus 2 all squared, and that is equal to 10. So what you're going to do now is expand, and then you're going to end up with x squared plus, this is now x squared plus twice the product of the 2. When you expand it, you get 4x plus 2 squared is 4. This is equal to 10. Cool. So now x squared plus x squared is 2x squared. So you have 2x squared plus 4x. And then now you have 4. Bring over the 10 over here to get minus 6, because 4 minus 10 is minus 6 equals 0. Then you divide through by 2 to get x squared plus 2x minus 3 equals 0. Yes, nice. So now we can just factorize. Boom, 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 boom. I know I'm not writing that pretty today, but oh well. We factorize and it's going to be x, 3 and 1. And it says signs are different, but the bigger one is positive. So put plus here and the minus here. So that means x equal 1. And that means x equal negative 3. Now if x equal 1, then put x as 1 here, so we get y equal 3. But if x equal negative 3, put negative 3 here. Negative 3 plus 2 mean y equal negative 1. So it's either 1, 3, or it's either 1, 3, or it's going to be minus 3, minus 1. That's it. Nice and easy, soft. Yeah, man, we're having fun. It's either 1 minus 3 or minus 3 minus 1. Option B. Easy. Now, before we even scroll up, let's look at this one. Two vectors are equal if they have equal magnitude. and they're going in the same direction. So have the same magnitude and same direction. So that looks like option B. Have the same magnitude and same direction. That's the only way two vectors are equal. All right, so nice. Go now. It tells us that question 23, it says the lines y equal 2x minus 7 and the line x plus y equals 7 intersect at. We need to solve them simultaneously. So substitute this line in this one to get x plus 3 times y. Y is 2x minus 7. That would be equal to 7. Expanding, this will become x plus 3 times 2x is 6x. That would be 6x minus 21 equals 7. And so that means that, oh, sorry, this is 7x because x plus 6x is 7x. 3 times minus 7 is minus 21. So that means that 7x equal 28. And so x equal 4. Since x equal 4, we can plug in 4 here to find y. Y is 1. Easy. So moving right along, it says two vectors I and j represent 1 kilometers east, north respectively. A man sails a boat on a lake such that the velocity is minus 1 plus 2 and there is no current. If the current is 3I, then the resultant vector is. So let me put it on a little graph so we can see what's going on. I'm going to use I and j as my axis. This is I, and this right here is j. And it tells us that a man sails on a boat such that the velocity is minus 1, 2j when there is no current. Minus 1, 2j. Minus 1, 2j when there is no current. So when I is minus 1, and then you have 2j right here. So this would be minus 1, 2j. All right, this is minus 1 plus 2j. Nice, minus 1 plus 2j. Minus 1i plus 2j. Then them tell me that if there is a current of 3i, if there is a current of 3i, if you add 3 to this now, add 3i to this, what's going to be the resultant? Add 3i from minus 1, add 3 to it, that's going to end up right here to be minus 1 plus 3 is 2. So that's going to be 2i plus 2j. So this resultant would have been 2i plus 2j. Now I know what you're saying, sir, your graph wrong because minus 1 should have been over here. So yeah, I mean, if you want to be technical, then yeah, a foolish I would have done here, then the minus 1 would have been right here. So, but we get the point, right? Don't make the graph sketch for us. So it's 2i plus 2j. It's option A, easy. All right, so don't make the graph fool, we'll just sketch around. All right, nice. All right, now question 26. Position vector of 2 points A and B relative to the origin are given by OA and OB respectively. Find the modulus of O of AB. First thing we need to find is vector AB. So first thing, boom, bang, we find vector AB. So vector AB is going to be OB minus OA. That's the first thing. OB minus OA. So it's going to be 8 minus 3 is 5. So vector AB is 5. Then 5 minus 0 is 5. And so that means that the magnitude of vector AB is going to be 5 squared plus 5 squared. So the magnitude, this means magnitude or modulus. The magnitude of AB is equal to the square root of 5 squared plus 5 squared. And so the square root of 5 squared plus 5 squared, that's square root of 50. Next thing it needs is the angle AB makes with the x-axis respectively. The first thing AB is 5, 5. So if we do one little sketch, AB is 5, 5. 5, 5 is maybe right here. So this is 5, 5. X is 5, Y is 5. And then want the angle AB make with the x-axis. This right here is the angle theta. So to find that angle now, what you can just do is say that the angle, you can say that tan theta, you want to use tan? Yeah, because we have adjacent and the opposite is 5. So tan of theta is 5 over 5, and 5 over 5 is 1. And so that means theta is tan inverse of 1, and tan inverse of 1 is 45. That's tan inverse of 1, and tan inverse of 1 is 45 degrees. That easy, don't it? Yeah, man, nice. That's 45 degrees. Yeah, man, we're nice. That's 45. That's C. Nice. So next thing now, it says, what is this trigonometric identity equivalent to? So we need to work out this sine x over 1 minus cos x plus sine x over 1 plus cos x. Okay, no problem. Let's do it right here. We have sine x over 1 minus cos x. And then we have plus sine x over 1 plus cos x. 1 plus cos x. This is what we have. Nice. So since this is what we have, first thing we need to do, yeah man, draw LCM. This is gonna be 1 minus cos x multiplied by 1 plus cos x. Yeah. Yeah man, this is what we have. And so this into this now is 1 plus cos x. So in the numerator, we're gonna then have sine x being multiplied by 1 plus cos x. Then right here, so we're gonna have plus sine x times in bracket 1 minus cos x. So if you want to simplify this numerator, I don't like how this looks. Let me just shift this up a little bit. Yeah. So if you want to simplify this now, we can realize that the numerator will become, you can realize that if you factor out the sine x out of the numerator, then you actually left back with 1 plus cos x. This will be 1 plus cos x, then plus 1 minus cos x, and then the cos x them gone. And then in the denominator, what we're left back with is 1 minus cos square x. But 1 minus cos square x is, yes, just like what you're thinking about, it's sine square. So this becomes sine x times, look at this now, 1 plus 1 is 2, so we can just write 2 sine x over 1 minus cos square is sine square x. Sine square x. And so that means, you know, a sine cancel out a sine. So the answer now work out to be 2 over sine x. This is 2 over sine x. Because a sine cancel out the sine. All right, so this is 2 over sine x. Nice. 2 over sine x, that never bad. Option B. Nice. All right, so continuing, it says, the figure MON below shows a quarter circle with radius 4. What's the perimeter of the figure? Well, they give us the radius is 4, and they give us this radius. We just need to find this length now, right? So to find this length, right, this length is on the circumference of the circle. So that part right here, if you were to find the perimeter of the whole circle, it would be 2 pi r, sorry, it would be 2 pi r, 2 pi times r, where r is 4. That would be the perimeter of the whole circle. But you just want this piece right here, which is a quarter of it. So we're going to divide it by 4. So this 4 cancels this 4, and so this length is 2 pi. So that means then, since this length is 2 pi, then the perimeter of this figure is going to be 2 pi plus 8. 2 pi plus 8. Instead of 2 pi plus 8 there, we can factor out 2 and write it as 2 times pi plus 4. All right, I really hope that makes sense. The perimeter of a whole circle would have been, perimeter of the whole circle would have been 2 pi times 4, but we divide it by 4 since we just want that small portion here. I hope that makes sense. All right, so that would be the perimeter of this part right here. Then plus the 4 and the 4 is 8, so 2 pi plus 8. Then we can factor out 2. Nice. No issues. Next part says the graph of y equal sine 2x. So first and foremost, anything with going up to 2 out already. All right, now what you need to do is plug in values. Always plug in values. Always plug in values. All right, and see if it works. So this is what I love to do. Draw like a little box. And remember, what is the function? The function is sine 2x. Right, so this is y and this is x. Now look at this. If you plug in x as 0, sine of 2 times 0 is 0. So it must start as 0. If it not start as 0, it out already. Once it start at 0. Next thing is, look at the values in here, 0, pi, and 2 pi. If you plug in pi, right, if you plug in, let's put pi right here. If you plug in pi, the sine of 2 pi should be 0. So if you see 0, it out. Pi is supposed to be 0, so them here can be it. And then if you plug in 2 pi, the sine of 2 times 2 pi is 4 pi, that should be 0. Now I'm just talking and I'm not showing you it on the calculator. So let me show you on the calculator. The sine of, this in degrees. So I need to put this in radians. So see there the sine of 2 times. If I put pi right there, see there's 0. All right, so now that we know that we're supposed to see it's supposed to be y being 0. There's a possibility all the 3 of these good so far. Now let's look at in between values now. What happens at maybe pi by 2? What happens at pi by 2? The sine of 2 times pi by 2 is the sine of pi, and the sine of pi is 0. So at pi by 2 it should be 0. So this one out, this one out. Yeah man, now let me show you why. You see it here now, when you put in pi by 2 right there, so you get 0, but this one now give you a y value of 0. This right here, when it's pi by 2, now give you 0, to give you 1, so this out. So now this might be it, pi by 2. Which other one is this one? Might be it too. So now them two you were left down to now. So now let's go even further. Let's look at pi by 4. If we put in the sign of pi by 4, let's see what we get. We get 1. Now if we have this pi by 4, do we get 1? Yeah. So this word is option C. Option C works. So pi by 4, yeah? Yeah, man. So option C works. Nice. Cool. All right. Now let's look at this right here. It says, find the smallest positive angle all right. Now it says, find the smallest positive angle in radians such that it satisfies this equation. Now this part out already was cos theta can equal 2. So you're only going to look on this part. From this part, you're going to end up get cos theta equal to a half. And if cos theta equal to a half, you just put it in your calculator. Cos inverse of a half. See there? Cos inverse of a half, you get pi by 3. That's the answer. Pi by 3. Option A. Easy. Nice. All right. Now it says find the exact value of the cos of 5 pi by 12. Now, just put in the calculator. right? This is not anything to do. Just put in the calculator the cost of, in bracket, 5, put pi over 12, put that in a calculator. Don't stress yourself. This is root 6 minus root 2 over 4. See there? Root 6 minus root 2 over 4, option B. Don't stress yourself. Good. This question now, it says, item 32 refers to this figure, find x. Well, looking at this, x equal 20 degrees. Straight away, angles in a triangle sum to 120, 180. So x equal 20 degrees. But if x is 20, we need to convert 20 degrees to radians. But remember that 180 is pi, right? 180 degrees is pi. 180 degrees equal pi. And so in order to get 20 degrees, we divide both sides by 9. Divide both sides by 9. 180 over 9 is 20 degrees. So 20 degrees is pi by 9. That's 20 degrees. Pi over 9. 20 degrees is pi over 9 in radians. Easy. Solved. All right, no issues so far. Continuing, question 33. If sine x equal s, then what is cos 2x? Remember that cos 2x is 1 minus 2 sine square x. That's cos 2x. But remember that sine x is s, so this would work out to be 1 minus 2 times sine x is s, so it's 1 minus 2s squared. Option C. All right. Then it says the sine of alpha minus 45 is what? Well, all you're doing is expanding in this right here. But first thing you have to know is that the sine of 45 is 1 over root 2. This repeat every year, so it's option A. This repeat every year. This is a big repeat question. All right. Question 35. If f of x is sine x minus cos 4x, what is f double prime? First thing is you have to differentiate sine 3x. When you differentiate sine 3x, f prime of x will be equal to, when you differentiate sine 3x, you get 3 cos 3x. Then you get minus, when you differentiate cos 4x, when you differentiate cos, you get minus sine. So it becomes plus 4 sine, 4x. Then you need to differentiate this again now. So that means f double prime of x going to be equal to, when you differentiate cos, you get minus sine. So we get minus 9 sine 3x. You'll get plus 16 cos 4x. That's what we get. Easy. This is the answer. So we're going to check which one give you this. They were nice. Minus 9 sine 3x. Minus 9 sine 3x plus 16 cos 4x is this right there. Good. Now it tells us that a curve has a stationary point. C is a stationary point at minus 2, 5. It says if f double prime is x to the 4 minus 15, and minus 2, 5 is what? First thing you need to do is find what is f double prime of minus 2. That's going to be equal to minus 2 raised to the 4th power, which is 16, minus 5, minus 15, which will be 16 minus 15, which is 1. And 1 is, of course, greater than 0. So that means this is a minimum point. If it's a minimum point, it's a minimum turning point. That's a minimum turning point. That's C. Nice. All right, now this one says, what is d by dx of 2x minus 1 over 5 minus x? So to do this question right here, it's quotient rule. So to the quotient, I'm just going to call this dy by dx just to make it easy. For quotient rule, it's going to be equal to, you start with the bottom, which is 5 minus x, multiplied by the derivative of the top, which is 2, minus the top, which is 2x minus 1, times the derivative of the bottom, which is minus 1, over the bottom square, over 5 minus x all square. That's it. So what we're going to end up get is that this will end up work out to be 5 minus x times 2 is really just 10 minus 2x, and then this is going to end up being minus and minus become plus, so that become plus 2x, and then we have minus 1 times minus 1 is plus 1 times minus 1 is minus 1, and then the numerator is just, as you can see, the minus 2x and the plus 2x gone. 10 minus 1 is 9. So this works out to be 9 over 5 minus x all squared. Just to write back the denominator, it was 5 minus x all squared. All right, now that's it. Yeah, man, we're having fun. Now the next part says, it says a point 1, 1 lies on the curve. Find the value of the gradient at this point P. First thing you need to do is find dy by dx and plug in the point 1, 1. But because we have smart calculator and we want to save some time, right? We want to save some time. Look at this right here. We want to find the derivative of this when P at 1. Just put this in your calculator. Just put in shift and this d by dx of the curve. The curve is 3x minus 2 over 2x minus 1, and you plug in at the point where x equal x is 1. Put that in, I get 1. So that means that the gradient is 1 at that point, and we're done. Nice. Nothing. We don't need to do nothing. Can't bother differentiate. Nice. Now it says, given that y equal to 2x cubed plus 3 sine x, what's dy by dx? When you differentiate 2x squared, you get 4x. When you differentiate sine, you get cos. So that's 4x plus 3 cos x. Easy. Now this one right here says, now, if the integral from 1 to 4 of f of x is 6, what is the integral from 1 to 4 of 4f of x plus 5? Now, if you were to take this 4 right here and put it on the inside, take this 4 right here, put it on the inside, then the integral from 1 to 4 of f of x is 6, but it's also being multiplied by 4. The dot mean multiplied by, and then plus 5. So that's 24 plus 5, which is 29. That's it. Easy. Yeah, man, we're having fun. Easy, 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 easy. Nice. Question 41. It says the region is enclosed by the x-axis and the curve this, and the lines x equals 0 and 1. Find r. R is the area, and the area is the integral from 0 to 1 of the curve minus x squared plus 2 dx. Now, that's how you find area. Now, I'm not in the mood to really integrate. I'm just going to show you what you get, because this is really a repeat question. So look at the calculator here, plug it in, integrate from 0 to 1 of minus x squared. This is minus x squared. And that is plus 2. And you close up the bracket, you're going to see the answer. 5 over 3. That's it, option B. Easy. This one now, easy to integrate. We know we add 1 to the power, and then we divide by the power. So it's 2x minus 4. We add 1 to the power, that becomes 4. Then we divide by the power of 2. Then we know that we put plus our constant c. So that is going to be, oh, sorry, add 1 to the power, divide by the power, then we divide by the differential inside the bracket of 2. Sorry, 2 times 2 is 4. And I don't see 4 there. Add 1 to the power, divide by the power. Oh, the power is 4. Why did I put 2? I don't know why I put 2. This power is 4 we're dividing by. This look tacky. Let's fix this up. This look tacky. Divide by 4, then we multiply by the derivative in the bracket of 2. So that is D. My apologies for doing that right there. All right. Question 43 says to find the volume. Always remember the formula for volume is equal to pi times the integral of y squared dx. That's how you find volume. So more than likely they're going to give you y and you have to square it. So in this case, we know that the volume is going to be equal to, we're integrating, it says from x equals 0 to pi, we're integrating y squared. Now this is 2 sine x. When you square it, 2 squared is 4. And then when you square sine, you get sine squared. So that's 4 sine square x dx. That's what you'd get. 4 sine square x dx. 4 sine square x dx, that is option. And you put the pipe on the inside. That is going to be, that looks like option 4 sine square is 8. Nice. Now we're done. It says if y is 3x squared plus cos x, what is the integral of y? When you integrate 3x squared, you get add 1 to the power x cubed, divide by the power. When you integrate cos, you just get sine. You just get sine x. And then you know you add your constant. So the 3 will cancel the 3. So that's just x cubed plus sine x. That's option B. Nice. When you integrate cos, you get positive sine. So now we're going to get sine x. When you integrate sine, you get minus cos. And so this becomes then minus minus becomes plus 2 cos x. That's how we get sine x plus 2 cos x. Easy. Sine x plus 2 cos x, which is D. So that's it. Nice. Because when you differentiate sine, you get back the cos. When you differentiate 2 cos x, you get back the minus sine. So that's it. This is 2020 Add Math. It's really nothing to it. 2020. All right. I just got hold of this paper and I decided to scan it, and here it is. Easy. So I really hope this video was beneficial, and keep on practicing. Add Math is right around the corner, and I wish you all the best preparing for your exam. Make sure to subscribe to help the channel grow. I really appreciate all the subscribers. All right. Have fun practicing for your exam.